All right, then we can get started. Sorry for a little delay. Whoever solves the problem of projectors, computers, and cables, I think should, I don't know, win some kind of prize, World Peace Prize or something, I don't know. But some kind of prize because it's always fun. Let's get started. My name is Rustam. I have a colleague with me as well.
Yeah, hi, I'm Mats.
Yay!
Hey.
The fan club, all the way in the back.
Lovely welcome here.
All right, so both of us, we work for a company called Computas. We have colleagues here in Romania, here in Bucharest, and we are from the Norwegian office, so we work and live in Oslo, Norway. We work with Java, we work with architecture. I mean, I'm a Java champion, I'm a Google developer expert for cloud, and, well, you can present yourself quickly as well.
Yeah, and I'm like no one developer. In the sense that I work with Kotlin every day for Norwegian Welfare Administration. And, well, on fun days, I go abroad with Rustam talking about serverless Java, which we're going to do today as well, talk about MicroProfile, Quarkus, Cloud Run, as examples of technologies which you can use to go serverless with Java and have fun on the way. So let's get started, because what we're going to talk about today is that the entire path from, well, I have some business logic on my computer available to me, no one else, I can hardly run it, and I want that business logic to be available for everyone, for all of you, in production somewhere. And I'm not really interested in infrastructure, so I want it to work. I want to be able, at the end of today, I want to be able to do git push, write my code, do git push, and then some magic happens and my code is available.
So I guess the short version, like if you summarize everything, we all have some code that we want to share with others. That's it. You know, you can't just write code, you can write amazing code as long as you don't share it with others. It's not that fun, maybe, right? I mean, right? It's like quiet. It's like you're totally wrong. Okay. Well.
Okay. And by the way, we have some hoodies hanging around here, really nice ones, which we're giving out to, well, to people asking questions or talking most with afterwards or something. We don't want to bring him home. So. Yeah. So what is our simple application? Like I told you, we had some business logic, right? And our business logic here is that we want an application that gives us 2 random words. Semi-random, sort of random, something. So
yeah, and the idea is basically to keep the piece of code, the logic of it, as simple as possible for this demo. You've seen this kind of noun-adjective combination thing that gives you back 2 random words back. You've seen it probably in Docker container namings. We use it in Norway. We've been using it for quite a bit for anything that does 2-factor authentication developed by, through. It's a kind of central login system. Don't really bother about the details, but the point is we have simple thing. Yep. Returns 2 words from 2 different lists. That's all.
That's all. And we accomplished that by, and this is the result. You can see we run 2 different times. We get 4 different words in total. So how do we get this code? Well, this is all the logic. Like, okay, there's some help methods, but like this is the logic. Read some either from enums or from a file and get a random element from each of them. So like super advanced business logic.
Now, how do you make this thing available? How do you make it available for anyone? Like, what's the most basic thing you can do? Any guesses? Like super basic, the thing you learn when you do Java at the university first week. Well, that's not first week. The suggestion was to package it into a library. That's a good thinking, but I want to go to your university now. But first week. Yes. So you slap on a main class. So public static void main, blah. It just runs, right? Does that make available to everyone else? Nah. Okay, so we need to go further. We need to dig deeper. And there was actually a little clue here. you can see, I mean, it still runs locally. It still says local host, but there is some things here. There is like a fancy URLs, and the return thing looks like kind of JSON-like. It's super simple, but well, it's a JSON. It's an array of strings. JSON, right? Okay, so how do we run that? So what we decided is to pick a stack. So this talk and this kind of thing was for the sake of the demonstration. Everything is going to be kind of opinionated. So we picked a stack for you, and then we're going to show you how to do it on that stack. You can do things in your own way. You can exchange things. You can do, for example, other tiny little kind of Micronaut or Spring or whatever Spring Boot kind of frameworks that will do that. We ended up going with Jakarta EE and MicroProfile. So this is our story. This is how we're going to show you, but you're more than welcome to replace parts of it. We're obviously going to explain why we did that and why you should do that as well.
And also what MicroProfile and to a certain degree Jakarta EE is as well. Yeah. So don't worry. But like, just to know where we are, how many of you kind of know Jakarta EE?
Jakarta EE, anyone?
A few of you, okay.
Okay, Java EE? Okay. So, it's the same thing now. So, well, it's been renamed, just so, so it's the same thing. Ish. Yeah. Not really, but ish. Yeah. MicroProfile? Okay. Yeah, it's actually
pretty good.
It was fun. It was more hands than for Jakarta.
And also more than we did a variant of this talk in Germany yesterday, and you were better than the Germans on this part. So congrats. So MicroProfile is a set of specifications for Eclipse for Enterprise Java microservices. And by that we mean, well, if you do monoliths, probably not suitable for you. If you do like a simple application as we did today, it's probably overkill. But like to show you how it can be used. So as it's part of the Eclipse Foundation, that means that there are working groups, there are ways to evolve MicroProfile, which is standardized and specified. And there are lots of organizations, vendors, individuals as well contributing to it. You can contribute too if you want to. So this is like, if you want me to summarize what MicroProfile is in one sentence, I would say it's Jakarta EE for microservices. And it's not true, but it's not true in the same sense that all models are wrong. All models are wrong, but some of them are useful. And like this is a statement, it's not correct, but it gives you an idea what it is. It's a set of specifications you typically need when creating a JVM microservice architecture.
So basically someone sat down, had some serious thinking, and was like, okay, we're going to pick these libraries, going to put them in one little bag, and we're going to ship them as a kind of an artifact to make your development of microservices easier. And then we'll see also a little bit about why and how easier, but we'll get to that point.
Yep.
So,
we told you that we're going to introduce Jakarta EE, and
I have to move to this side.
Yeah, so like here you can see that there's a lot of blue boxes and different colored boxes on this slide. Like all those gray boxes are not part of MicroProfiles are not included in our talk, but those are.
So this is a one, in a picture that you will see on the next slide, this is going to be one box, because this is a MicroProfile piece that's called a Jakarta Core Profile, which has some really basic stuff that you need that, right? So we didn't fix that typo. So it's not Cloud Light. I know we were talking about Cloud World and Cloud Native and all this, but it's actually CDI. Regards from the autocorrect. But CDI Lite for JSON. Well, you kind of need JSON, right? You need annotations, you need interceptors, you need to do some RESTful stuff. JSON again, dependency injection, all this kind of stuff. So this is kind of a thing that you really need to have in your typical microservice application, because without all that, you can't really do web services.
Yeah, and in Jakarta, in MicroProfile, you can see that box is on the bottom here.
This one.
Yeah, and this image is kind of nice in the sense that the rest of MicroProfile kind of builds upon the Jakarta EE core profile.
But I mean, if you look at it, and like, remember what I said earlier, that it's kind of opinionated box of the different libraries that were added on top of that. You see, I mean, we had all this fun stuff in Jakarta EE core profile, but then on top of that, it adds some things, because for developing a microservice, you need to be able to, I mean, think of a microservice that typically is a cloud-native application, right? For cloud-native, you need to be able to show how your app is doing. You need to have some kind of fault tolerance. You need to have a REST client would be very nice to have an open API to be able to document your APIs and stuff like that. Config, you know, all those kind of things that actually bring something to the table. For example, again, if for the cloud-native applications, you might want to be able to scale them up and down automatically. We'll talk about that in a bit, but for doing that, you need to have some kind of metrics. You need to know how your application is doing, so you need to, well, yeah, metrics 5.0, health, fault tolerance, you know, it's really, really nice to have those things on top of that anyway.
Yeah, and like, speaking on top of, I'm sorry for you in the back that we have some text on the bottom here, so you probably maybe can't see, but like the blue boxes, they are not changed from the last version. So this is MicroProfile 6.0, came out in the end of last year. The yellow ones are updated since last version, which was 5.0, I think. And the white one on the upper corner there that's new. It's open telemetry, so for tracing, logging, monitoring, and so on. Maybe even metrics someday. We'll see. And we could talk a lot about all of this, but like, yeah, if you find some of them either confusing or interesting, specifically interesting, come talk to us afterwards.
Come talk to us, we'll confuse you more. Don't worry about that. There's no problem with that part. We're not going to talk much about this part. It's very fun, but we're going to keep it on the side because it's kind of outside umbrella, but it's still compatible with MicroProfile. And yeah, and speaking of you in the back, I'm also sorry because I kind of feel I'm always in the way of the picture, so I kind of keep on dancing here. But you know, interpretive dance. I always wanted to do a talk.
Yeah, but I guess we could add the 2 sentences that open tracing is deprecated. Use telemetry instead. If you have long-running actions, if you look into this one long-running action LRA. If you do reactive stuff, look into reactive messaging, GraphQL.
GraphQL is really fun. Yeah. I mean, that's my kind of personal favorite of the outside umbrella things. I don't know. Yeah. But okay, let's move on.
So who is behind this thing, Rustam?
Yeah, well, who's behind this thing? It's a community-driven thing, and behind that is a community. Community can be several different entities. You see like a big companies that are, I don't know, Oracle, Microsoft, Red Hat. It's a big enterprises. There are small, well, IBM there as well. And there is also a smaller communities, actually. So Java user groups, Atlanta JUG over there, the German umbrella, JUG umbrella, iJAG, and Garden State Java user group, and so on and so on. So it's actually, it's a mix of bigger companies, smaller companies, and also Java user groups as well. So basically anyone can contribute, and then these are the people that are part of the working group that get to decide how things develop and which direction, and so on, so on, so on.
Yeah, and for those of you who are not that into like nicknames of American states, the Garden State is New Jersey.
Yep.
So, well, so now that's a brief overview, like what MicroProfile is, but like, okay, we know what it is. Why should we use it?
Because complexity. No, actually the opposite. Because, well, you've heard the keynote, right? Us developers being attracted to complexity as like moth to the light. Well, this is kind of the attempt not to do the opposite. So you really want to write your code and not the boilerplate. I mean, it's really fun to implement, I don't know, web HTTP calls and everything maybe once. To maintain it, not so much. To make sure that you fix all the bugs and security issues, very not so fun. So, you know, you let somebody else who's good at that actually maintain that, and you just use those libraries, and you just use it as is. You just, you know, you write some code, you annotate it with something, and boom, it's, you know, it's a REST endpoint. Yep. It's lightweight. So lightweight in many senses, but generally it's also does not pull all the libraries that you do not need to have. So it will just add a few ones. So you could always I don't know, if you would you just pull the whole Jakarta E thing, and it would be kind of a big thing with a big footprint. Now they also did Jakarta E did a very smart thing of separating in different packages and things like that. But here it's a smaller, condensed, opinionated thing that provides you the functionality they think you need. If you need more, you can just add them yourself manually.
Yeah, and I would like to emphasize a little bit on that, because, yeah, it's lightweight in the sense that as a developer, if you're using MicroProfile, it follows from that, well, you're using REST services, you're not using SOAP. So like, that's a decision you don't have to have in your head. Like, you don't have to consider so many opinions, because it's opinionated, as Rustam said. You are using JSON. You're not using XML or YAML or
SOAP.
Yeah,
Did
or
anyone
whatever.
say SOAP? Did anyone remember SOAP? Did anyone have good memories from SOAP? Okay, 2 hands. Nice.
Great. So it's opinionated, but it's also interchangeable. And what do we mean by interchangeable? We mean that, well, if you write your code using entirely either Jakarta E or MicroProfile or a combination, which you can do, and you want to switch from, I regret my choice of app server. Like, I want to go from this app server to another one. To do that transition, and we'll show you a guide on that towards the end of the talk as well, you don't have to change your Java code at all.
And it's it's an important thing to actually underline here again is that it is a specification. Both Jakarta E and MicroProfile are specifications up to the providers that claim compatibility to actually implement that, run tests, and say, hey, we're actually officially compatible with this thing. So that also means that you can most of the time just move around things by just changing your configuration without changing your code. That's cool.
That's really cool. So what can you choose from then? Well, you can go by any of these implementations. So again, there are logos you probably see. Helidon from Oracle down here. Mm-hmm. You have Wildfly and Quarkus made by Red Hat. We're going to talk more about Quarkus later in the talk. You have Launcher from Fujitsu, Cumulus EE from Cumulus in Slovenia, Tommy from Tommy Tribe, Apache, and you have OpenLiberty from IBM, Payara Micro. Yeah, and I think Piranha may be coming up as well. So there are things happening, but currently these are.
So I mean, what we'll be talking this talk mostly will be Quarkus and maybe tiny little bit of OpenLiberty. So, but yeah, the thing is you can move around and things like that.
Yeah, like the important point here is that there are several of the implementations. So where do I start? That's like the typical question. Oh, I like this idea. I want to look more into it. Maybe it's approachable, applicable to me. Maybe not. How do I find out? Well, one place you can go is to the MicroProfile starter, which is rather similar to, like, say, Spring Initializer or Initializer from different other projects. You type in, like, well, who am I? What's my project? Which version do I want of this? Which version do I want of that? And so on. Which, yeah, it can be somewhat dated on some of the versions. So it's like, have a look and see if it fits what you're looking for. And if not, look into a specific implementation. So
what usually happens is that the providers of different runtimes, they have their own starter pages, and those starter pages, if they support MicroProfile, would typically include MicroProfile. Like, for example, with Quarkus, where you can actually search MicroProfile and you get the implementations of that, and then you get, like, yeah, there you go again, GraphQL, MicroProfile, and so on, so on, so on. So if you do not find whatever you're looking for in the general the starter page, try looking at the other providers, because they do implement things. They sometimes implement in a little bit different speed. Yeah.
Yeah, and like if you already are using, say, OpenLiberty or Quarkus or whatever, you can add MicroProfile dependencies to your POM file or your build Gradle file, and then you're good.
Yep. So now it works on my machine, right? It's the classic thing, you know. It works on my machine. I have made it. I wrote some code. I tried slapping on the main method. It really wasn't a really good idea. I tried now adding a MicroProfile and a Jakarta E and all this on top of that. And now it works, but it still works on my machine. I just get to run it locally. What do I do now?
Yeah, so what do we do now? well, you know, some years ago, we developers used to say, yeah, it works on my machine. And then someone said, oh, nice, so let's ship your machine.
So that's how project managers threatened us. You know, it's like, you like your machine, right? Yeah, well, you make it sure that it runs on the others' machines as well. Otherwise, we'll ship it in your machine.
Yeah, and we did that by containers, right?
So that's why we invented containers. So now we can actually shove everything into a container and say, hey, it's containerized microservice, that monolith that we have been developing for the last 20 years. But, well, we'll get
Been there, done that, by the way. Yeah.
We'll get back to that later. But the point is, you want to containerize it because of several reasons. One of them is reproducible builds. And the other one is that you actually have a reproducible deployments as well, which is a really nice thing. You actually can say, well, you know, it's been built on this architecture, it behaved nicely, I'm going to build it on the same, I do not need to build it again, I can just actually ship the same artifact around and it's going to be used on different environments, different development environments or staging or QA and so on, so on, so on. That is really nice, right? But so the Docker is just an example. There are other ways of containerizing things. It's actually a standard now, so you know there are providers for that as well.
Yeah. So, but if you are going with Docker, or like even if you're going some else containerization technology, you should consider, like Sander talked about in the keynote, things like multi-stage builds. If you're doing building first and then you're doing container like the production container afterwards, you can do it in separate steps, so like you don't leak Maven into production.
I mean, this slide could have been a talk in itself and probably like a workshop for a full day as well, because there is a lot of things that you really need to think. It's like multi-stage builds. How do you build your stuff inside a container, but do not keep all the building stuff with you, all the kind of things that you don't need anymore, like say you're building with Maven, you build it inside a container with Maven. How do you ship your container that's much, much, much smaller without all the .m2 folder and you know all the Maven stuff? Well, multi-stage builds. How do you make sure that it's small-sized, well, slim base images, also thinking of what to keep and what to delete? Also, how do you make sure it goes fast? You can actually think about layers. How do you do your layers so you don't have to redo those layers and change anything? Because the way it works, it just adds more layers on the storage, and if you change anything at any level, it will start from that, change and go down again. If it doesn't change, it just jumps over. But if something changed in the middle, it will start from that earliest change. And that's, you know, sometimes if you do Maven, for example, you don't want to download the whole internet every time you do build stuff.
Yeah, and if you do NPM, you definitely wouldn't.
Yeah, then you download the internet 3 times, I think.
Yeah, and now instead of downloading the internet, we are pushing our code to the internet. So we have made our logic, we have made it run on our runtime or app server, or choose the name you want, and we have built it into a container, which in theory could be pushed anywhere. So we want to take that container and, well, make it someone else's problem, so push it to the cloud.
Because we want to make, remember, we want to make our code available for people, and we're still on local host. No, we put it in the cloud, so instead of downloading internet, we make internet bigger. Yay. There's a lot of bad jokes coming today. I don't know. It's
Yeah, we're on a roll today, but like, so this is, yeah, I get, like, how many already have automated builds? Yeah, quite a few.
Good.
That's good. Like, we would really encourage you to do that.
Ooh, this is fun. Wait.
Okay.
How many of you have automated environment setup and stuff? Yeah, there you go. It's fewer. Really, really good. So the thing is, the point is you need to automate as much as possible. And when you think you're done, you should automate some more. Because there is never enough automation and there is never enough to do that. At some point, it's just somebody is coming and stopping you from doing it, and then you kind of still try to do that. But try to automate everything as much as you can. And, well, first you start with builds. That's kind of obvious for many of us. We started probably with, I don't know, Jenkins and all the other CI platforms. Now we have GitHub Actions, we have Cloud Build, we have all the million kind of things that we have to do the building. But a lot of people don't think about setting up and tearing down environments. So like things like Terraform and Pulumi or something like that, doing infrastructure as code and all this kind of thing. So try to automate as much as possible. So that's kind of the gray area here, and everything else goes. Yeah. So
yeah, and this is of course a prerequisite for the fact where we started, where I want to do git push, and then the code to be somewhere in production.
You don't have, I mean, not all of us are Willy Wonkas. We don't have minions working for us like, Oompa Loompas. So we use CI/CD platforms, I guess. One of the ways of doing that's cloud built. It doesn't have to be, but we picked a platform, so we ended up using cloud build for this. You can use GitHub Actions. You can use anything else. You can actually install a VM, put a Jenkins on it, and just go crazy with Jenkins if you want to. The good thing with this kind of one-stop shops that cloud providers usually provide is that you have all the things integrated in there, so you don't have to think much about the kind of the products that you're going to be using later. You can just say, hey, I want to deploy to this and that, and it usually would be set up in a much easier way. So that was kind of the motivation behind that. And here we do somewhere, yes, there. Yeah. Push to branch. So whenever a push comes in, it's like, oh, I can build that, and then it just goes crazy.
Yeah, and you can connect this to like whatever Git repository you want. At least you can connect it to GitHub, which we have done. I think you can do like custom Git address as well, but you can connect it to GitHub or use like Google's own Git
source code repository thing that is also as a part of the cloud. That's also possible. You can also set up things like, there's many ways of doing that. You can also set up a GitHub with a mirror to the source code repositories, and then actually building from those if you want to. It depends on your setup, on your corporate stuff. We've been working on some projects where Git is behind firewalls, so you need to do something about that. Sometimes it's a public or open source repository, so it's open for everything. So there is a few modifications, but definitely it's possible to do it in one way or another.
Yeah, so that's like, the event type here is one thing you need to know about. The other one is build configuration. If you need to do something specific in your build, you can specify it here. Say, Google, of course, have their own YAML style cloud build files. Rather similar to what GitHub Actions have, or the Jenkins file from GitHub Jenkins, and I guess Azure DevOps has something similar. So nothing specific there, but like if you need to do something specific in cloud build, you typically use that YAML file. Or you could do it here in the UI, but don't do that. At least not for something serious. So we'll have a look into the cloud build YAML in a moment. Yeah, this moment actually. Because
the moment you've been waiting for.
Yeah. You'll probably already have created a Docker file, right, as we talked about. And maybe that's good enough. Maybe you don't need any more configuration for your build than that. And then that's fine. But if you do need more, you can...
You can specify things in YAML, and we all do love YAML, right? But the point is that, if you want to do something that you can specify in Docker file that's specific to cloud build, this is where it goes.
Maybe we should show an example.
We could show some examples.
Okay, so now I'm on a new computer. Always fun.
So we have a totally brand new computer. We're not logged in on anything. So it's going to be very fun.
Okay, so...
That's kind of the extreme program.
That's him.
Right?
Hopefully you recognize him.
It was me.
So we can look like global YAML file. So this is some config for OpenLiberty. Well, this is really small. So let's first look at the raw mode to make it bigger, and just the text we need, and then make it somewhat bigger.
Maybe not that big, because then people in the back can see the bottom.
Okay. Yeah. So
tiny, a little bit smaller. Minus.
There, perhaps.
Yeah.
Alina, is that good? Yeah. Great. Okay, so here's like the global YAML file. It's rather short, but here we do the main build inside our cloud build. So that means that whenever we do git push, and the trigger you saw on the previous slide picks up that, well, there is a push, then this happens, and it starts with doing Maven verify. You can do Maven verify. You don't need clean install on these things. That's a sidetrack. Then we do like build container. And we have an error, but that's okay. You should do some push here as well. And then you see here we do run deploy. So we actually deploy the image that we
So the
create.
thing is, it's important to actually, when you create the containers, you actually want to reuse that container for all the environments, for all the things in your pipeline. So you put it into the container registry. So GCR is an example of that. So this is a Google Container Registry, but it can be any other container registries as well.
Docker Hub or GitHub or whatever.
And all these random strings you see everywhere, that's the name of the project. That's what I called it when I created it. I didn't realize one thing. So D and S on the keyboard is very, very close to each other. And sometimes you mistype. And yeah, I kind of almost started a side project called Ransom Strings. That's a different one.
We don't talk about that one on
we
conferences.
don't know. That's another side project. Well.
Yeah, so let's move on, because now we have built a container image. It's in the cloud somewhere. Now what? Well, we have to run it.
No, we're not done. We're actually going to put it on serverless because, so the thing is, the motivation behind this slide and behind like trying to tell you to do this is that a lot of people say like, hey, you know what? Google is running on Kubernetes, Microsoft doing, Amazon is doing that, Twitter, Reddit, whatever. Everybody's running containers. I'm going to run my application on containers on Kubernetes as well. And then you're like, oh, cool. How many users do you have? Oh, it's like 3 on a good day. You know, it's like maybe you don't have the same kind of need for the, many node Kubernetes clusters that you have to manage yourself, do all the crazy stuff with it, and like, encryption, rotation of the secrets and all this blah, blah, blah things. Well, the serverless comes to the Rex group because you can actually deploy it. You don't have to go to the cloud. You don't have to go to the public cloud even, or private cloud for that case matter. You can go to even on-prem serverless solutions like Knative or something and deploy there. That is a way of making sure that your application is able to scale up and down. It's kind of more elastic application, so it will go up when it needs to, when you have those 3 users on a happy day coming in, and when there is no users, it kind of goes to sleep and just, somewhere there ready to be started, but you're saving money. You're not using money or hardware. So on the public cloud, it would be equal to money because you'll see it on your credit card bill, but on the like on-prem solutions, you'll see it on the hardware utilization. So you have to basically buy less servers, or you can deploy more stuff on the servers that you have. So that is the serverless part. And now that we've sold you serverless, well, we can talk a bit more about serverless.
We can talk somewhat more about serverless. So this is what we have done. We have taken that container image we built in the previous step. Now we have pushed it into Google Cloud Run, which is Google's building on top of Knative, at least used to be. So like, think of it as, Google manages serverless for us. And of course, it integrates really well with Cloud Build. So that's why we chose those two together. But like, if you can do Amazon Lambda or whatever, whatever floats your boat in that part. So the important thing is that here it is, now it's running.
But the cool thing is that, like, one thing I mentioned, it goes up and down. That's cool. But sometimes what you can also expect typically for serverless platforms and platforms like, managed platforms in general, because serverless, it doesn't mean there is no servers, right? There is actually, I like to call it manageless. It's like, it's less management. It's maybe not all management is gone, but it's much less. And the thing is that you want to do things, for example, like A/B deployment, blue-green deployments, A/B testing, blue-green deployments, all those kind of things that you want to do. You want to split traffic, for example. You want to deploy a new version of your application that you want to test and see how it works. So you kind of route 5% of your traffic to that, keep 95 on the other side, on the old application, see how it behaves. You monitor it, use the health and metrics and all this kind of error logging and all this kind of things to understand that. You can do this with platforms like this. So for example, in this case, you'll see that there is saying, this version has 100% of traffic, but you can actually do split of that. You can say, 5% or something, and the rest can go to the other version, and so on, so on, so on. And you can see all the red ones. It's like when something fails, and then you just build again. No, I'm going to fix it. No, I'm going to fix it. 1, 2, 3, 4, 5, 7 red, 2 green. Actually, 3 green.
Yeah, and now we're good. So now we have built it.
now we're not going to break it ever
Yeah,
again.
and voila, it's available online, done. So that you get Breezy backup, and if you run it again, you get another one. So it's done, but we also said that, well, or maybe we didn't say that, but we want this to be fast. Which is next slide, sorry. But like, yeah, we've spoken about serverless, why serverless is great, like what the best features of serverless, but there are also situations where you really shouldn't go there, right? So like if you have a constant number of semi-constant load, you have users all day, like it varies between like 150 to 200 users every 20 minutes, the entire day. You probably not need the flexibility, right? Or like if you have an app server that, if you have an application that uses long time starting, you have a long startup time, that's a no-go for serverless. Like, well, it actually needs to start up the application whenever a user comes, and if that takes a long time, you get the point.
And when the calls come in, for a cold start, there's two things happening, right, in serverless world. First, somebody, some of the Oompa Loompas in the cloud world wakes up and is like, oh, there is a request. Cool, I need to kick that container going. So it starts the container, and then container starts, and there are some nested Oompa Loompas in there. They need to start your application in there, so they're kicking your application. So first, the container is starting. The second one is actually your application starting inside the container. And now you have two things to think about. And you know, when you develop serverless applications, that part is important because, you know, on the internet, when you send a request and it takes less than a few milliseconds, it feels like an eternity, right? And then it's like, no, I'm going to use another service. This is too long. And this is what is important here. So the startup time and for both container and the application is an important part. Cold starts is a very big issue, especially when you set up on your serverless platform, go to total full zero. The cold starts is an issue. Back in the days when I started developing code and working as a developer, like 15, 16 years ago, we would just deploy things on the Tomcat, and Tomcat on a Windows or Linux server or something. You would just create a thing, and then you would just figure out, we have a memory leak of this library thing. We'll just restart it on Sundays, and then people coming in and complaining. We're like, oh, well, you know, on the Mondays people complain because the response time is so slow because of the cold start. Oh, well, we'll just put a cron tab thing, just ping the server early in the Monday morning, and everybody's happy, right? You can't do that anymore. You can't do that with serverless because you don't have control over this. And just for the record, since this is being recorded, it's a very bad idea to do so. I mean, back in the days, you would just do it because you could, and you were, you know, nobody really told you that not to do it. Now I'm telling you, so now you can't do that anymore.
Yeah, so now you should instead go fast. So let's go fast with a racer car, because that's the way you go fast.
This is funny. Emojis on Windows and Linux behave in a totally different way. Imagine, close your eyes, imagine this is a big red, fancy racing car.
Yeah, it's red on my Mac and blue on the screen, so that's fun. But as we told you already, there are several implementations of MicroProfile, right? And they have different strengths. And one of them, Quarkus, which we're going to talk a bit about now, is like, it's made from Red Hat some years ago. It's made with the intention of being run inside a container. And when you're running inside a container, you know your environment. There aren't that many dynamic things going to happen. That means, next step, that you can actually do lots of stuff at build time. When you are creating a container, you know what beans you're going to have in it. You know so much about it. That means the more you move into build time, the faster you can start up, because you already know many things, so you don't have to do it when you start up. And that's why we've chosen to use Quarkus for this type of applications.
And Quarkus also has a lot of plugins. We're not going to talk about that. It's not a really Quarkus talk, but we're using it, and it's worth mentioning. So all these little bubbles that you see in there, it's the kind of plugins that you can use and pull into Quarkus. MicroProfile, obviously, so there is some Kafka stuff, Camel, Kubernetes. I see some more stuff in the back there.
I think that's Keycloak to the bottom. And
yeah, so that's the point. The point is that there is a good infrastructure or ecosystem that where you can pull both the official Quarkus images, but also stuff from Quarkiverse that is a more community maintained part.
Yeah, and I think, like, for the record, most of the tools and application servers and so on we're talking about today are open source, so you can have a look into it. But we promised you, like, almost 40 minutes ago, that we're going to show you how to migrate from one application server to another one. And I already told you you don't have to change your Java code or Kotlin code. Everything here works perfectly fine with Kotlin as well. That's pretty cool. But like, oops, sorry. So the step-for-step guide is like, find the starter for Quarkus, download it, adapt the POM file to your project. Like, you probably have some custom dependencies, you have some name group IDs, artifact IDs, and so on. Or like, it's the same for Gradle, by the way. So move config to application.properties, which is where Quarkus stores things like username and things you set in environment variables, what kind of environment you're in, what database name, all these things. You update your globally.yaml file, which you already talked about, run. And then run again after you fix the bugs, but like, this is the brief overview.
Hence the red things that you saw earlier.
Yeah.
But I mean, the thing is, why do you want to do that? And why Quarkus is that just the startup times is important thing here. And we've done a talk here a few years back in exactly the same room, well, not exactly the same room, but the same building, where we talked about other things about MicroProfile, and we were actually comparing the startup times where normally runtimes would start really, really fast for being a runtime, but then you would put another microservice running Quarkus next to it, and before even the other application servers or other runtimes would start logging that they're actually starting anything, Quarkus was done. So it's just like, it's just a few milliseconds and it's done. So it's actually a very, very useful thing to have, especially in the context of the serverless where you really want fast startup times.
And no, we're not affiliated with Red Hat, even though Daniel from Red Hat comes in exactly when we're talking great things about Quarkus. Okay, but now we have to switch over to Quarkus. You can see that in the URL, that's random string Quarkus and works.
How do you make things faster? You add 2 racing cars to it. I mean, still imagine those are really nice and cool red racing cars. This is,
pretty good.
Talk to Microsoft about that.
And maybe we didn't make a separate slide on that, but like, okay, so Quarkus starts pretty fast, like fast enough for many situations. But if you are running, say for instance, a backend for front end, so you have a web page, and the user does a login and does some backend calls, and you do that backend with Java or Kotlin. Even though Quarkus starts fast, it doesn't start fast enough for a user not to get tired of waiting. So you have to
because actually, just to give you you remember I told you about this 2 level of startups on the cloud. It's a bit more. First, some minion has to pull it from container registry. Then the same minion has to kind of put it on to make it start, and then you need to start your application. And then there's a few levels of abstraction happening. So somebody has to instantiate the containers for running the containers, because in the cloud everything runs in containers. And then you have like turtles all the way down. It's containers all the way down, I think. But yeah, how do you make it even faster? So, again, to the back row, we have Red Hat, we have GraalVM in the back there. So, well, you go. So the thing is, the Quarkus has 2 modes. It has JVM mode and it has native mode. When it goes native, it actually uses GraalVM in the background to compile things into binaries. So you don't have to deal with a little bit of overhead that you have from JVM and stuff like that. It will take you a little bit longer to build it, but then it will go faster. Because your users, we developers, we kind of love long building times most of the time, because we can slack off and it's compiling kind of thing, right? But users, they don't really like waiting, because they just don't like that. So we can actually make our life a bit more fun. We can have a bit more fun while it's compiling. Go get a coffee or 5, and then you can actually make users happy with a slow, fast startup time. Sorry.
Yeah, I think we even might have time to show. We can try to show some of it, but like, you're like everything else is a trade-off, right? Because if you have applications running for a long time, well, you should probably run JVM mode for a while, because JVM handles that thing. But like, if you're doing serverless and so your application spins up and down pretty fast, like the overhead from JVM, you probably might not need it, but then you trade it for longer building times, as we already said.
So the thing is, the plan was actually to show you some code in IntelliJ with proper highlighting and like, you know, all these nice things.
Yeah.
We have it set up on 2 different machines. Both of the machines are Mac, and the projector thing is not talking to Mac again. I don't know what happened, but so now we're going to do actually live GitHub stuff, because everything...
We can do live GitHub stuff, actually.
Yeah, we can do that. And because everything is, as you can see, it's publicly available on GitHub, open source-ish in a sense.
Yeah.
And then you can see all the stuff that we have been doing and
so
changes as well.
Here you see we have several...
Actually,
you probably don't see, but you should have seen. No, you might see. We have several Docker files here. One just named Docker file, one Docker for Quarkus and Quarkus native. And we also have some different cloud build files as well. So, yeah, but what we can do, what I can try to do, this is crazy stuff to do live, not. Let's log into GCP. Sorry, buddy, it's not meant to be your account.
Switch account? Well, you know what?
I can do guest accounts.
Yes, perfect.
Yeah.
Exactly.
Okay. So this is like, I'm running a new computer, which is not mine. Always fun.
It's always fun to forget to log out afterwards.
No, but like we set up. We have set up a project on GCP.
I'll cover his password.
I'll try to remember it myself. So. Thank you, last boss. No, but like, okay, Rustam does some talking. I'll log in.
Yeah, sure. So what we're going to show you a bit is that we actually deployed it to the cloud in several versions. We did Open Liberty one just to show it works in just regular kind of runtime and everything. Then we did the JVM version of Quarkus as well. And then we also have the Graal, the native mode of Quarkus as well. And
I'm just trying to do login, so
yes,
this
is
me.
Fantastic. I can verify it to you. I think it is.
Okay, so here's a project. It's called Random Strings Vox Bucharest. I should increase it again.
Yep.
And you can see on the left side here, it's Cloud Build and Cloud Run. So on Cloud Build, as always, we do some experiments. So that's a lot of red things. But you can see, like, here we have 3 different Cloud Build triggers. Which are, each of them have their own build configuration cloud build YAML file. And each of them has the push to branch event. You can see I've disabled 2 of them while working on the 3rd one. And if we look into, say, this one did native. So here we did the native build. It took 2 minutes and 41 seconds on this demo application. We used some caching tricks from Kaneko. Which is like caching layers of Docker and Maven and everything in GCP and other clouds. So you can see like we did that, and we did a run deploy. So you can see the service URL has. So that's a URL in Cloud Run, which you can head over to. And you can see Quarkus native here. Oh yeah, by the way. So typically each trigger relates to one of these Cloud Run applications. So Quarkus native relates to Quarkus native, as you could guess. And you can see where we have a Cloud Run setup here, memory limit 512, and so on, deployed 2 hours ago. And here you can see a URL. So no, I haven't invoked this in a while, so all the servers are shut down. And so we have 0 instances, and whenever I click this link, it will start up.
It's going to be cold start now.
Yeah, and so I can even do like copy to clipboard, so you can see that I do this / health to see the health checks. And here we are.
Yeah, that was cold start. And that's the health thing is actually, comes from MicroProfile. You don't have to do anything about it. Well, you can always say add more metrics to it and stuff, but, and I have another talk where I explain and show this kind of things, but here this is what you get default out of the box.
Yeah, so let's look into the logs here, see what happened. Because it's always fun to watch logs, you know, especially someone else's logs.
Oh, yeah.
So here we can see 12:28, that's now, just an hour off time zone thing. So 12:28, 17, 3:26, something happens. That's my call. It's a Quarkus starter. And yeah, it started like, here it is, yeah.
2 milliseconds.
Yeah, 200 milliseconds and everything was up running.
So this is the cool thing when you want to use serverless. This is what you need to think about when you create the Java applications. The other thing is that Java, people write a lot of things on the internet. There's always somebody who's wrong on the internet. But people say like, oh, Java is old. Oh, Java is like, it's slow and stuff like that. Well, it's not. I mean.
Yeah. So like we can even do, this is Quarkus JVM mode. I think this application is small enough that it starts pretty fast as well, but let's see. For comparison.
Tiny little bit slower.
It is. Okay, this is interesting. There it is. So let's, okay, we're running out of time, but let's hope that we can see the logs first. And sorry for not giving you time for questions. You can, we'll stay here for the rest.
So there is a room, the open spaces room thing. So we can go there and we can talk if you want to, or if you don't know where it is, just meet outside. We'll just go there.
Yeah, so you can see it takes a couple of seconds.
Oh, you have a question? Okay.
Great.
Okay, do a question.
Have you done this in real life production?
Yep.
He did.
Yeah, I actually did. I have it. Oh, I can show you. It's not dangerous.
Yeah, of course, you can always set minimum distance to 1, but that also feature came in after we were developing that as well, by the way. And also, sometimes you don't even want that.
Yeah.
So that's the thing. Yes. Yes.
Yeah. So this is my production, actual running instance in production. This front end is nothing. Yeah, the front end is Cloud Run. So this application is running Cloud End in the back end. And whenever I do login, I spin up the back end and does the login. So do I have time? Oh, sorry, we're running out of time. But the answer is yes. This is Quarkus native base. Yeah. I tried with the JVM version first and figured out, okay, this is fine on my computer. As a user, I won't wait 5 seconds for the login to happen. I will think that something has crashed and go and do something else. And like that's where the Quarkus native really has its place. So it uses Quarkus native, and yeah, you can have the code as well. So
I guess we should show some contact information for us if people want to ping us. And
oops, we've been signed out.
Okay.
Oh, that's too bad. Well, we are here.
We are here.
Obviously,
ping us. You'll be able to.
Rustam is on GitHub. I'm on GitHub.
Yeah, we're on Twitter as well. So look at us. Look us up on Twitter with the same name. So.
Yeah.
Thank you all for coming. We'll do questions.
Thank you.